So what happens when the data you need to teach an AI is just a complete mess? It's a massive kind of behind-the-scenes problem in the world of artificial intelligence. Today, we're going to look at a super clever way to fix it without having to just throw everything out and start from scratch.
All right, let's frame the problem this way, because it really gets to the heart of it. Imagine you're trying to train an AI, but its teacher, the person who's supposed to be labeling all the training data, basically falls asleep on the job. What do you do then? This isn't just a funny thought. It's a huge challenge that developers face all the time.
Okay, so to really get the solution, first we have to understand the problem. And it all starts with the standard, almost textbook way that most AI models learn to see the world.
This classic method is called supervised learning. And honestly, the flashcard analogy is perfect. You show an AI thousands, sometimes millions, of examples that a human has already labeled correctly. An image of a cat gets a label cat, a dog gets dog, and so on. After seeing enough examples, the AI starts to pick up on the patterns itself.
And this is where it all goes wrong. On the one hand, you have the perfect scenario. A human carefully labels every photo, apple, pear, whatever, and you end up with a really smart, well-trained AI. But then, there's our big problem. The human just doesn't do the work, and the whole system breaks. Without those labels, supervised learning is literally impossible. The AI is just sitting there with a mountain of pictures, completely confused.
So, if that main road of supervised learning is totally blocked, we got to find a detour, right? And the answer is a really clever hybrid solution, one that actually combines two different ways for an AI to learn.
Here's the big idea. You basically let the AI do the heavy lifting first. We're going to start with an unsupervised method, which means the AI just looks for natural patterns in all those unlabeled images. Then, once it's done that, we use the tiny bit of information we actually have to help it connect those patterns to the right names.
So step one is all about creating order out of chaos. Before the AI even has a clue what an apple or a banana is, it just starts organizing that huge, messy pile of photos into neat stacks that look visually similar.
This technique is called unsupervised clustering. The AI just analyzes all the pictures of fruit, and based only on things like color, shape, and texture, it starts making piles. All the round red things go in one pile. All the long yellow things go in another. It has no idea what they're called yet, but it's already creating structure where there was none. And this isn't a quick, one-shot deal. The process is incredibly thorough. The AI will try grouping the images into 20 clusters, then it'll try again with 15, then 10. To make sure the results are really solid, it even uses 3 different algorithms and then cross-references them to see which patterns are the most stable and common. It's kind of like asking 3 different people to sort the photos and then seeing where they all agree. Okay, so the images are now sorted into these logical groups, but now for what I think is the magic part. Building a bridge from a picture to words that a computer can actually work with and compare. The AI doesn't just see a picture of a red apple like we do. It does this deep analysis, breaking the image down into raw data points. We're talking color ratios, shape complexity, surface uniformity, all that good stuff. And all that visual data gets turned into a simple descriptive text string. So now, that picture of an apple has a text profile. And this is the key, because it means we can finally compare the image to the text keywords that our lazy labeler actually did provide, like the words apple or pear.
All right, we've got our sorted groups, and each group has this text description of what its images look like. Now for the final step. It's time to play matchmaker and give each cluster its official name.
For this, we use something called an attention algorithm. Just think of it like a super intelligent search engine. It takes the text that the AI generated for a cluster and compares it to the human-provided keywords. Then, it calculates a similarity score to find the absolute best match. It pays attention to the most important words. You can see it right here. When the AI's description for a cluster is red, round, stem, the algorithm sees a 95% match with the keyword apple and only a 10% match with banana. I mean, it's a no-brainer. Same thing for the yellow, long, curved cluster, a 98% match for banana. Boom! The algorithm can now confidently slap the correct label onto each of those clusters.
So after all that, the clustering, the converting to text, the matching, what's the final result? What's the ultimate payoff for doing all this clever work? The payoff is this. We've completely bypassed our unreliable human and automatically generated a high-quality, fully labeled dataset. We've basically taught the AI to create its own perfect flashcards. And now, finally, we can go back and use that traditional supervised learning to build a really accurate model.
But, this solution isn't some magic wand. It's important to be aware of the potential roadblocks. You can have information loss when you simplify a complex image into just a few words. The clusters themselves can be unstable. Their quality can change depending on your settings. You can also have mapping errors if your similarity scores aren't calibrated just right. And of course, there's scalability. This can get pretty slow and expensive if you're working with truly massive datasets. These are all really critical trade-offs to think about.
And all of this leaves us with a pretty provocative question to chew on. We started this whole journey with a problem that was caused by a human not doing their job. And we solved it by teaching an AI to do part of that job for itself. So as AI gets better and better at fixing its own foundations and prepping its own data, you have to wonder, what's next? How is our role in all of this going to keep changing? It's a fascinating thing to think about for the future.